All right, well, welcome everybody. Thank you so much for coming out today. My name is Mark Nordell. I'm an application engineer here at CAD Technology Center. And today we're going to be talking about working with topography in Revit. And so this will be an introduction to topography, just kind of talking about the basics of how we work with topography in Revit. And so within this course, we're going to talk about how to use the tool set that's available to us, but then we're also going to create some topography from scratch and then learn how to control the graphic quality of those contours that it produces, and then also learn how to use pre-existing civil data to create topography that we may be getting from outside consultants. And so ultimately, in a lot of cases, we're going to have to start our topography from a set of lines, and we may have gotten that set of lines from a civil engineer somewhere, or maybe it's just a PDF set that was provided by the owner of the project, and we really only have some two-dimensional information to work from. So we're going to take a look at how we can utilize that, and really we're going to look at how Revit creates topography within it, the project environment. And so ultimately it's defined by points, which we'll see here in a little bit. And we need to manipulate those points to define the contour lines that we would actually produce. And so this being the case, I'll just point out that there are a couple of limitations with working with Revit's topography, in that our civil departments actually use what's called a tin surface. And so it's a triangulated surface that is extremely accurate to what the landscape or what the grading for that particular site is going to do. In Revit's case, it's a bit less accurate, and most of your civil consultants probably will not know how to use Revit, and they won't actually have any input as to how you would create your topography from their information. That being the case, it does require a lot of collaboration with those consultants that we might be working with, so that we make sure that we're getting all of the information as accurate as we can while still representing it in a way that's graphically pleasing in our set. And so without further ado, let's go ahead and just jump out into Revit. And so right now I've just started a Revit project. This is just the basic architectural template. There's nothing all that special about it. You could start from any template that you prefer. The only thing is that we need to be on a particular view that can see topography. So in this example, in the architectural template, if we go to the site plan, that actually has its visibility and graphics to show all topography, and its view range is set appropriately so that we can see all of that different information that we might be laying out. So just to start, working with topography, all of our tools are going to be found under our Massing and Site tab. And so starting from the left on this panel, we have some massing tools, and these might be useful for creating, say, context buildings or just context masses that we might use. But kind of right in the middle of this file, or right in the middle of this tab, you'll find topography surface, site components, parking components, and then there's a few more options that at this point are grayed out, which we'll see how to use those in a couple of minutes here. And so first, let's just go ahead and we're going to select the topo surface and see what it's asking for. And so ultimately, once we enter into this command, we enter into a sketch mode. And right now, Revit is looking for us to place a point. And so you'll see that that point has a specific elevation that comes up for it. And so we could choose to give this a particular elevation that's accordance with our site plan that we have. So maybe this is real elevation data, say like 963, and that's how many feet from sea level this point would actually be. In our case, I'm just going to leave this at 0 and just pretend we're at the right level at this point, and we can just place some points around. And so you'll notice that if I place a point, nothing seems to really happen. It shows a point in the file. Place out a second point, nothing really seems to happen again. As soon as we have our third point in line, you'll notice that it starts to triangulate a surface. And so in Revit, it looks to triangulate that surface based on the points that we lay out. And so as I lay out a fourth point, we now have a rectangle. And I'll go ahead and just hit my green check button to finish this particular topography surface. And I'm going to move out into a 3D view so that we can see what we've made. And ultimately, since we placed 4 points at an elevation of 0, we've in essence made a flat topography surface. And if I select this surface, you'll notice that it's now defined under topography. We can add materials to that, and we can add a different phase if necessary. So now, in most cases, our topography is actually going to have some type of slope to it. And so let's go ahead and take a look at how we can manipulate that slope and make it match up with things that we're actually using within our current project. And so if we go back to a site plan, and I select that topography surface, if I already have a topography surface, I can edit it, or I could do this right from scratch. In our case, I'm going to go ahead and edit this surface that we've created. And you'll notice that I can select these points after they've been placed out, and I can change their elevation. And so in this case, I'll go ahead and change this to, say, 10 feet. And I'm just going to hit my green check button just so that we can see what happened. I'm going to go out into a 3D view, and now we can see that from this corner, our site now slopes down towards the center of the site where it flattens out. And so ultimately, if we need to go through and be more specific and more explicit about where those points go, we can actually go through and specify that. So let's just go back to our site plan, select my topo surface, hit edit surface, and I can choose to add more points. So in this case, I'll go ahead and add some more points in at, say, 10 feet in elevation. Maybe I want one here. And as I place those points around, Revit then triangulates a surface based on what I've chosen there. And so now we have more of a mound, and we have some contour lines that follow down the site to show us where those might be cut and what the elevational height is at those different points. So now that we've created a topography surface, you'll notice that there's some other tools that have now become ungray in our massing and site tab. So before we had topo surface, site components, parking components, and the rest of these were really grayed out. And so number one, let's talk about a building pad. And so a building pad in Revit is much like a floor surface, only what it does is it actually cuts through the topography and cuts down into it. And this might be useful for creating, say, foundation systems, or just cutting out holes within the surface that we would like to build into. And so you'll notice that a pad is much like a floor. And so I'll go ahead and edit the type just so that we can see the structure of this. And so it just has a name. Right now it's given by default a pad 1, but this could be a 6-inch concrete slab on grade that's used as the base slab of the building, or it could be a slab in a basement, whatever it is that you choose. And a lot of firms also choose to just use this and then turn it off, replacing it with a particular floor. And so, but you'll notice that the structure of this pad is very much like a floor. We can go through and we can add constituent parts to that, move those up within the system or down within the system. And we could just build this as a floor. Really, the main difference between this and a floor is that a floor obviously does not cut through our topography. And so in certain cases, if we already have floors defined, again, we can hide this element within the view, simply just cutting through our topography, leaving the impression of where we want to build. Another thing that comes up often is that we may need to split this surface. So you'll note that when we select our topography surface, we can add a material to it, but very often we need to add multiple materials in this to represent other items like roads, or maybe even other divisions of forest versus grass areas, or whatever it is that makes up the particular topography. And so we do have the ability to go ahead and split these surfaces once we've created them. So I'll go ahead and choose split surface, choose the surface I would like to split. I can draw a line where I'd like that to split, and now I have two separate portions of topography surface. I can create, or I can change those materials then to different materials depending on what they're actually used for or how I would like them to graphically display. This also could be a way of dividing the surface into areas of proposed work versus existing conditions that will not change as well, allowing us to then adjust phasing options created for those different constituent parts. So if there was ever a situation where we accidentally split a surface but now need to merge it back together, we can always select our merge surfaces and select those two different portions, redefining them again. Another option for this is that if we don't necessarily want to split the surface, but we just want to divide this particular area by material. And so maybe we just want to add in, say, a parking lot portion with a road that goes out to another main road or something like this. And so we can choose to add a subregion. And so a subregion essentially lives on top of this topography surface, but will allow itself to adjust according to the slope of that particular topography surface. And so now if I go out into a 3D view, and I'll just change my graphic display to something realistic so that we can see what's happening here. And so now if I was to choose a different material for my subregion as I did for my topography surface, you can see that they get shaded differently, they will be rendered differently, and better yet, that subregion element follows my topography and matches up with it exactly. And so this was very useful for things like roads and sidewalks that need to match the slope of the topography, but are not necessarily needed to be physical elements that we can work with. Another very useful function within Revit is that you're noticing that when we draw out this topography, it is putting in contour lines for us. And so you'll notice all the way to the right side of our Massing and Site tab, we have the ability to label those contours. And so I'll go ahead and select my Label Contour tool. And essentially we just draw a line out and intersect it with all of the different contour lines in our topography surface. And when we place that out, it will now display to us what the height value for each of those contour lines is. And so the next thing that will come up often is that we may have cut a section through this particular building, and let's just pretend this area where we placed our pad is actually a building, and I'm going to cut a section through our entire site topography. And in this section, maybe this building goes down further than what this topography allows. So I'm going to go ahead and give this a negative 20-foot value. And so what if my hatch is not actually penetrating all the way down to the base of where my building actually exists? And so we'll note that under our Massing and Site tab that there are some options for this. And so if we find this little drop-down arrow to the right side of our Massing and Site category here, we'll open up our site settings. And so this allows us to set the increment of our contour lines, as well as the hatch type and the hatch elevation or the depth of that particular hatch type within our sections and elevations. So in this case, I'll push this down to say negative 30 feet, and now it sits below my building, but just past. And so you can really dial that in depending on what you're trying to build, how deep you're trying to build into the topography surface. But by default, the system is going to come out at a negative 10 feet. So if you do have a lower structure and it's a parking ramp, you're most likely in a case where it's 18, 20 feet. down below grade and is going to allow or is going to require for this to be adjusted for you. Another thing that comes up often is how do we manipulate the graphic of these contour lines that we're placing out. And so you'll note that we can modify this through our visibility and graphics. And so if it's on a particular plan that we want to change, but we don't necessarily want this change to be made globally, we'll find under our topography category that we can set our primary and secondary contours. So we could go through and we could specify a type of line pattern for that, and maybe it's a dashed line, maybe a dot line, maybe a different color. And we can redefine those lines however we choose. Now that being the case, this is just a override to this particular view and not a global change. So if you're looking to make this change to your overall model, we will find those changes to be made through our object styles. And so if we scroll down in our object styles under our Manage tab and we go to our topography, we will now find the line work for our primary and secondary contours. And so now we've created some topography. We've learned to work with a couple of the tools, and ultimately, if you remember back, topography is driven by simple points. And so we define points, and then Revit goes through and extrapolates how many contour lines to place between these two different points. And as we move those points around, Revit dynamically adjusts that and makes the changes as necessary. Now in this situation, it was quite loose. We just placed out points exactly where we wanted them to be placed. But in most situations, you're probably finding yourself in a position where you don't get to just choose what happens. We're following some type of existing topography that we need to work with. And so a couple of options that we have here is that we first looked at just placing points and just placing them manually where we would like to. We can also create topography from imported objects. And so there's several different types, but mainly we will want to pull information from selected import instances. And so in this model, I'm just going to go ahead and hit cancel on this. And I'm just going to delete this topography surface out for right now. And so in a lot of cases, we're going to have an import that we're going to work from. And so in my case, I'm going to go ahead and import in here just a simple line work surface. Maybe this came from AutoCAD, maybe it's a PDF background that we're placing into the file, but you can see it's just flat line work. There's no three-dimensional qualities to it. We could then go through and draw out all of our different topography lines. We can also use three-dimensional information to create that, and so I'm going to go ahead and import one more option. And so this may be something that comes directly from our survey consultant. And so you'll notice that whereas our line work came in right at 0, or at whatever level we placed it, in a lot of cases, if you get information from your civil consultants, it's going to have real-world values. And so it's going to have real-world latitude and longitude, excuse me, but it's also going to have accurate elevation from sea level values. And so in a lot of cases, if you do import these items, they may or may not be visible within your different views depending on your view range and depending on how those are set up. So if you're ever importing an object like this and not seeing it, make sure that you zoom way out because again, the longitude and latitude will be specified, so it may not be coming in exactly at 0. And then again, the elevational height, if we look in elevations, is going to be above our 0 level, which in civil, they're going to call that 0 in most cases sea level. And so whatever the height of that actual elevation is at that site location is going to be what's chosen. And so in this case, civil has already done a lot of that work for us, and we have this site import. And so one thing that we could do is we could utilize this line work, for example, and I'll just move this off to the side. to actually draw out and follow this line work. So this might be the case where we're trying to draw this based on a PDF, and it has actual number values in here to tell us exactly what height that should be. And so in one way, we could go through and select our topography surface, select our height based on the height specified on our plan, and just simply utilize that line work to go ahead and draw out our particular line work. You can see as I follow this line work around, it's going to start placing out those contours for me. And one thing that you'll notice in Revit is as you place those points out, sometimes you're going to have points that don't seem to really be doing a whole lot. And the reason for this is just that there are some inaccuracies with how Revit works with topography. And so one distinction to make when working with topography in Revit is that, like I say, with our civil surfaces, and so let's go ahead and take a look at this one, this is a very complex tin surface, or it's a triangulated surface that's very accurately placed based on a set of points defined within AutoCAD. And so in this case, it would have been created with AutoCAD Civil 3D. And those points are placed quite close together. And you'll notice that even in our Revit file, like I just pointed out, sometimes we have them placed together correctly, but Revit will just ignore you and draw a line across these two points that we're not intending for them to be drawn across. In those cases, we have to manipulate the model and add other values. So if I put another point behind this and say call it 9'6", now even though this point is floating in space, we're being more explicit about what we want from Revit. And so now it starts to recognize those other points. And so ultimately we have to go through and we have to manipulate those per each contour line and per instance, and maybe even have to add in a few intermediate points to make those lines become more accurate. Now, if you are lucky enough to have contour information brought in directly from a civil consultant, you can just go ahead and make topography surfaces from that civil tin surface or a 3D object that they export. And so instead of just placing points and going through and placing a point on each one of these vertices, we can actually just choose to create from import and then select the import instance. So in this case, I'll select my topography surface. And then it's going to tell you, or it's going to ask you, which of the layers within that AutoCAD drawing do you want to create this information from? In my case, it's this V Topo Tin, and I'll say OK. And it's going to show me that it's saying that that the surface could not be auto-detected, but Revit will impose different points to try to fix those issues. And so this is one of those situations where you can see that the accuracy within Revit is not quite meeting the accuracy that you would have seen coming out of Civil 3D. And so ultimately there will be some mistakes in that. And so let's just go ahead and hit our green check button to finish this topography surface. And I'm going to go out into a 3D view, and we will just go ahead and hide our import. And now we can see that our roads are coming through quite clearly, but areas where it's going to start to break down is going to be at curb lines and sharp areas where there's a tight level of accuracy. And so this is where you might come back over the top of this topography surface and clean it up utilizing building pads or a combination of building pads and floor systems to redefine things like the roads. But we could also, just like we saw before, go through and split these surfaces or go through and actually draw subregions over the top of this to represent different materials that we might use. And of course this can save us a lot of time, but it's definitely a bit difficult in that, like I say, the information coming from a program like Civil 3D is often much more accurate than what Revit can handle. And so one of the last things that I'm going to talk about today is that often when you're importing this information in, before I mentioned that civil information often takes on real-world coordinates within whatever software it's being built in. So in Civil 3D, they will actually specify the geolocation on Earth where this topography is coming from, and possibly tie that to other GIS data out available on the web or through different databases that they have access to. And so ultimately, when we bring this into Revit, it may not place it directly at our origin. And so right now, in the case of this particular import, it's coming in exactly where we want it to be placed. But other than that, like I say, in certain cases, we may find that we zoom out and our topography is located way off to the side of our model. And this is based off of those real-world coordinates. And one limitation that you will run into with civil information is that Revit has a 25-mile limit in all directions. And so this means that if that topography surface or that tin surface that we're getting from our civil department is more than 25 miles from our origin point, it will not show up within our file. It will show up as though it's imported, and it will show up as though it lives within this file, but we will not be able to see it from any of our views that we have within our model. In that case, we need to go into the civil model and actually redefine the origin point or redefine the way that we import that information. And at this point, you would definitely want to coordinate more with your civil department to make sure that everything is being done properly and that our real-world coordinates are not being lost. But ultimately, I just wanted to bring that up because this is something that commonly happens when we import information into our Revit files. And so I'm just about out of time for today, and so I'm just going to wrap up here, and I will leave it open to questions. If you guys have any questions or you'd like to see something again, go ahead and let me know, and I can make that happen for us. Thank you so much for coming or for watching this webinar today, and it was definitely a pleasure. Yes, this webcast is being recorded, and we typically then turn around and display this out on YouTube. So if there was anything that we went over quite quickly, I realize that this is a quick tutorial. You can go back to watch this again and watch it at your own pace so that you can keep up with the different things that we've been talking about. And I do believe that you will get a link to this, but I'm not positive on that. You may have to search if you are looking for it. You can find our YouTube channel, and it's just our CAD Technology Center YouTube channel, and you'll find all sorts of these videos, and if you just search based on topography, it should come up at the top of that list. And I have another question just for those who are not able to read this, so that they would love to see how you align real-world coordinates between Civil 3D and Revit. And so I'll point out that this is not a small undertaking, but there are those, or there are a couple of people within our office who have gone through and actually done a lesson on this. And so we have an excellent architectural consultant. His name is Sean Zerbis, and he's one of our evangelists for technical software. Him and our civil engineer, Brian Lewandowski, actually put together a video, and you can search for this video as well on YouTube to actually coordinate between Civil 3D and Revit. The problem with this becomes that it is two separate platforms that are fundamentally different from one another. And so ultimately, like I say, there are definitely accuracy issues. There are limitations in the size and the amount of space that we can use, or the file size, or the drawing limits within Revit that aren't existent within Civil 3D, for example, or in AutoCAD. And so ultimately, these being different platforms, there isn't necessarily a right or wrong answer to this, but a couple on our team have really come together to try to show the best practices for this. And like I say, it's no small undertaking. I think that the video is upwards of an hour and a half to 2 hours long, just to understand how we would be going about this. But ultimately, the lesson to be learned is that we need to coordinate with our consultants and not just expect that it's going to happen easily. There is work to be done on both ends, and once you kind of wrap your head around it and understand what is causing the issues that you might be be encountering, then you can work with your consultants to overcome those. But it's going to be about developing a workflow with those consultants that makes sense for both of you and is economical and produces the graphic result that you're looking for in the end. And so I'll definitely point you to those. Definitely just look up shared coordinates, and you can find this video on our YouTube channel, again at CAD Technology Center. Okay, all, I'm getting the red light and I'm supposed to get out of this room, but it was a pleasure teaching all of you. Hopefully you were able to take something out of this lesson, and definitely check out our YouTube channel. There's plenty more videos just like this one, short, sweet, and get straight to the point on how we might use some of these tools within Revit. Thank you so much, and you guys have a great day.